A long uniform chain of length L and mass m is lying on a smooth horizontal table, and one third of its length is hanging vertically downwards over the edge of the table. If G is acceleration due to gravity, work required to pull the hanging part onto the table is given that the part of length of chain hanging is L by 3. Therefore, distance of center of gravity is L by 6. Weight acts at center of gravity is equal to mg by 3. Therefore, work done W is equal to F into S, mg by 3 into L by 6, mgl by 18. By the way, two rectangular blocks A and B of mass 2 kg and 3 kg respectively are connected by a spring of spring constant 10.8 Newton per meter and are placed on a frictionless horizontal surface. The block A was given an initial velocity of 0.15 meters per second in the direction shown in the figure. The maximum compression of the spring during the motion is clear that the conservation of linear momentum and the conservation of energy can be applied. Let the mass of the blocks be MA and MB. Let the initial velocity given to the block A is MA. Since the two blocks are connected by the same spring, final velocity of the combined is nothing but the combined velocity of the blocks together. Therefore, final velocity V is equal to 0.06 meters per second. On applying the conservation of energy, the energy given to the block A is equal to the kinetic energy possessed by these two blocks together plus energy of the spring. Therefore, on simplifying this, we will get the maximum compression in the spring is 0.05 meters. If the work done by a force in moving an object through a distance of 20 meters is 24.2 joules, then what is the magnitude of the force? We know that W is equal to Fs, F is equal to Ws, which is equal to 24.2 by 20 is equal to 1.21 newtons. A drop of water of volume 5 into 10 power minus 8 meter cube falls from a height of 100 meters. If G is equal to 10 meter per second square, what is the work done by the gravitational force? V is equal to 5 into 10 power minus 8 meter cube, H is equal to 100 meters, acceleration due to gravity 10 meter per second square. Then density is equal to mass by volume, mass is equal to density into volume. The work done can be calculated by using the formula F into S. If the force is the gravitational force, that is equal to mg into h. On substituting these values, we get the work done is equal to 0.05 joules. Horse and a dog are running with same speed. If the mass of the horse is 10 times that of the dog, then what is the ratio of their kinetic energies? Observing the data, it is clear that let the mass of the dog be m1 is equal to m, mass of the horse m2 is equal to 10m. Since their velocities are equal, kinetic energies can be compared by taking the ratio ke1 is to ke2 of mv square by 5 mv square. Therefore, ke1 is to ke2 is equal to 1 is to 10. 4 kg and 1 kg mass are moving with equal kinetic energies. The ratio of their momenta is the relation that exists between kinetic energy and momentum P is K is equal to P square by 2m. Since the kinetic energies are equal, Ke1 is equal to Ke2. P1 square by 2m1 is equal to P2 square by 2m2. P1 square by P2 square is equal to m1 by m2. P1 is to P2 is equal to root m1 is to m2. So the ratio of their momenta is 2 is to 1. Carries a load of 50 kg through a height of 40 meters in 25 seconds. If the power of the man is 1568 watts, find his mass. Basing on the information given in the problem, let the mass of the load m is equal to 50 kg. Height through which the body is raised is 40 meters. Time taken by the man to bring the load is 25 seconds. P is equal to m plus m dash into gh by t. On substituting these values, we get the mass of the man m dash is equal to 50 kgs. An engine is used to lift water from a well of depth 10 meters at the rate of 9000 liters per minute. Find the power of the engine if 20% of energy is wasted. Volume of water is 9000 liters per minute. Therefore its mass is 9000 kgs. Time taken by the engine to lift water is 25 seconds and depth or height is 10 meters. On substituting all these values in the formula P is equal to mgh by T, we get the power is 14,700 watts. Since 20% of the total power is wasted, only 80% of power is utilized. Therefore 80% of P is equal to 14,700. Therefore power of the given engine is P is equal to 18,375 watts. What happens to kinetic energy of a body when 1/4 of mass is removed and velocity is doubled? This problem can be divided into two cases. Let the actual mass is m1 is equal to m. So 1/4 of mass is removed means m2 is equal to 3/4 of the mass m. Velocity is doubled means let v1 is equal to v. In the second case, velocity is doubled means v2 is equal to 2v. For initial kinetic energy ke1 is equal to half mv square. Kinetic energy in the second case after removing the 1/4 of mass ke2 is equal to 1 by 2 into 3/4 of mass into 2v whole square. Therefore ke1 is to ke2. Ratio of kinetic energies is equal to 1 by 2 mv square is to 1 by 2 into 3 by 3/4 of m into 4v square. And comparing the kinetic energies or the ratio of kinetic energies, we get 1 by 3. ke1 is to ke2 is equal to 1 by 3. Therefore ke2 is equal to 3 into ke1. Therefore after removing 1/4 of mass from the body, final kinetic energy ke2 is equal to 3 times the initial kinetic energy. ke2 is equal to 3 ke1.